This customer is a regular customer, and what he wanted me to do is mount a tire on both the front and rear and install the rotors on this front wheel. It's aftermarket. He said it was Chinese stuff. And then, you know, inflate the tire, balance it. But I figured while it was sitting here in the Nomar, I'd just go ahead and slam that rotor on. And therein lies the problem, because it doesn't fit. It doesn't fit in this spot here. You can see it has these bosses that it sits in, these shoulders rather. There are 5 shoulders. That's important here. And the distance between here and here is very difficult to measure, if not impossible, because you can't get directly across from it. I imagine Starrett or somebody makes a tool for that. But I'll show you a trick as to how you can do it with math. Anyway, here are the rotors. Arashi rotors. Again, these rotors, I tried both of them, they won't fit on that side of the hub. And it isn't the powder coating this time. The powder coating is clear. I even went around with a needle dick file and made sure. This bore here is simply too small for that spot on the wheel. Now, how I came to measure that is using 3 micrometers. I used a tubing micrometer to get the average between 3 or 4 of these spots from the inside of this bore where the bearing goes. Luckily, the bearing's not already in. And then took that number, multiplied that by 2, or simply added it together, and then took the diameter of the bore itself, which, why am I walking away, and then took the diameter of the bore itself and added it to that. And I came up, I'd say plus or minus 1 thou at 3.1585 imperial, and then measured this up, and just using a spring gauge and a 3 to 4 mic, and it's about 5 thou smaller. Hey folks, me from the editing cave. I wanted to do a little sidebar here in regards to measuring that to figure out how much I needed to take out of that rotor. That probably would have worked, except for the fact that I didn't realize it at the time, but the bores are screwed up on these wheels where the bearings press into, the axle bearing bores. That's what I measured from the edge of that boss over to the inside of that bore, and then just doubled it and then added the diameter of the bearing itself, or in this case the bore, which is also bad because here's what happened. I didn't know it at the time, and I did see that there was some sort of a funky surface finish on that part. But again, take a look at the zoom up and you'll see what I mean, that this thing has been sprayed with something like a prep coat or something for powder coating, because at the time that I did the work, I found out later, customer said he bought those rims off eBay and they were chromed. So apparently the powder coater must have had to do some sort of a primer spray or something on it to get the powder coating to stick to chrome. I don't know. I don't know who this powder coater is, but I've complained to this customer a number of times that he's sloppy as hell and gets it where he shouldn't get it. In fact, I already told him I'm not doing any more work on any of his stuff if it's powder coated, because it's just too much of a pain in the ass. So with that issue in those bearing bores, the measurement's invalid, and I figured it out later when I tried to put the bearings in. I'm like, what's going on? So I took a dial bore gauge. I got a couple of stills of that too. Over that short distance, about an inch depth on one of those bearing bores, had a 5 thou taper, 2.5 on the side. And it wouldn't even come close to let those bearings seat in there, or start in there even. So the bore's completely screwed up. I had to hand grind essentially with a Dremel, with the little drum sanders, to get that crap out of there. And you can see in the pictures here, I'll put another one in, that it's a little copper color because of we're down to the point now where that's where the chrome got scraped off as well by my process. And now that's what the prep work is for chrome. I recognize that. So again, it looks like I got screwed by the powder coater again. My customer did, because I had to charge them a couple hours extra for all that. But I did get the bearings all the way in. And the reason why I mention it is I said about 5 thou difference. You're not going to believe how much I had to take out of those rotors, the inside of those rotors, to get them to fit, which you'll see here shortly. So I just wanted to add this clarification at this point. So now you'll have the accurate background information as we move forward. And I guessed at 5 thou the way it fit. Let me show you. I guessed at 5 thousandths. It just felt that way. I said, you know, this thing's about 5 thou too small. I got to be really careful here, because I don't want to mar up the powder coating. But you can see it just, there's no way it's going to go on. So So I called a customer and I said, what do you want me to do? Do you want to return these or do you want me to make it work? And he said, make it work. So that's what we're going to do. I want to chuck this preferably right on these guys here with a 3-jaw, not a 4-jaw, because I counted the number of these. 1, 2, 3, 4, 5, 6, 7, 8. There's 9 of them. 4 isn't divisible into 9, but 3 is. So a 3-jaw chuck will work on this because 3 is divisible into 9. Now we'll go over to the lathe. I definitely have the swing for this, but we're going to have to put the outside jaws in. And what I'm worried about in the outside jaws is it'll be this surface turned around, it'll be facing in, that we're going to have to get into that surface, and that kind of is like a triangle shape. I don't know if it's going to fit. So let's go ahead and get the outside jaws in, and then we'll bring over one of those rotors and see if this works. That's the only part that I'm not 100% sure of, but there are ways around that as well. There's a couple ways we can actually do this, but I wanted to make sure that the jaws would actually fit into this hole. And as you can see, they just do. So that gives us 2 options. We can actually clamp downwards on it, or clamping inwards, or we can clamp outwards. And we got a machine surface, sort of. I'll have to show you this by moving this around, but we have somewhat of a reference. So, but the thing is, if we do clamping inwards, I'm really worried that it's going to damage this edge because the edge of the jaws are sharper on the inside here. I'm going to bring the camera around and show you what I mean here. So we might just clamp outwards and put a couple little pieces of sandpaper between there if there's enough room. I don't know if there actually is. I don't think there is enough room. I don't think so. I don't think I can even get a couple of thousand shim. I mean, this barely fits in there. It fits, but it barely fits. Normally what I would do is I'd take like a pop can aluminum and I'd stick it in between surfaces like this, but this is all the movement we got. And I don't think there's going to be any way to do that. So if I go out with it, in other words, I'm opening up the jaws, we can fixture that right up against there. We'll indicate it to make sure, but give it somewhat of a tightening. What I mean by what I said before was, you can see down inside there, see there's a little lip in there. Let's see if I can point to it with a screwdriver. There's a little focus. There's a little lip right in here if it'll focus. Right there. See this little lip? This is a better way to see it. You can see it in the reflection. And that lip is only kind of straddling, if you will, part of the face of that jaw. So will that give us enough reference to make sure that we are square with the chuck? I don't know. Like I said, we're going to run an indicator across it. But we definitely have the swing. There's no question about it. And all we need to do, and there's clearance to the jaws from this inside of this bore here, as you can see. So this part right there, you got clearance. We only got to take 2.5 thou to 3 thou on a side off to make this fit, if my calculations are correct. I want to indicate the bore, and I want to indicate the face. So I'll probably indicate the face right here where it's uninterrupted, like just inside the bore. So let's do that first and see where we're at. I'm going to go a little further out with the indication because all I might have to contend with is these etched numbers, because there's just not a whole lot of material between the holes and the slots in the center of the bore. And I sure as hell hope you can hear me because of the fans, but it's really hot. Okay, so right there we're low by about 3 thou, 2 thou, so, which ain't too awfully bad. And right there we're high by about 1 thou. This is not super critical, but I'd really like to get it as close as possible. And it's right on those numbers, so you'd think it would be actually high, but those are recessed in, like etched in. All right, I set the 0 on a high, so it's 3 thou low, very close to where it was in the exact same spot. So what I'm going to do is I'm going to try to take it and put a little piece of paper behind that, because a piece of paper is between 3 and 4 thou. That'll work. Then a thou. Now I'm only going to be taking an extremely light cut. What I was going to do as well, I want to indicate the bore. Now that's actually the important part. Whoa, what the hell?
What the hell?
I can't be that far off. Now, why in God's name would that be that far off? Well, this is going to be a problem. I figured it'd be dead nuts. Look at that. Look at this indicator. This indicator's going like to Mars and back. That's not even close. All right, we need to regroup here because this may not work. I'm not really certain what the hell's going on with this. Concentric. Should be fairly concentric with the spindles, what I'm trying to say. All right, let me get back to you on this. Okay, I think I know what I did wrong here. I cannot grab the outside of these jaws and be accurate on concentricity because they are unmachined. Or they're not machined very accurately. You can see they're not ground, that's for sure. So that was pretty stupid of me to think that. So really all we got to do is, instead of clamping out, we're going to have to clamp in on these things. So let me get this out of the way. The edges of these jaws, see how they're chamfered? Well, that chamfer almost matches the angle I'm set at on this rotor exactly. So that's kind of cool. And those should be a good reference. Well, I'll tell you what, there is so little room in there. I got some tissue paper and I went and raided the wife's stash. I don't have any rolling papers. That's another thing that people use. Machinists use those all the time for shimming and stuff. But I don't roll my own, so I couldn't tell you anything about that. I don't roll anything. Roll tires and things like that, but that doesn't sound very exciting now, does it? I thought you guys would appreciate the pink. Let's see what it looks like now. Yeah, that's still pretty far out. Yeah, I don't know. There's no room to shim this. There's no room to do anything, and I can't use a 4-jaw. So this might be a bust, and you'll never see this video. Yeah, that's a 10 thou swing. 8 thou swing. I don't know why. That's another problem, is if I could seat down on the jaw itself, and I can't back it off enough to put a shim in there. Really clamping on that angle, that bevel of the jaws. So again, this is one of these tricky situations that you try to work your way through, but sometimes you just can't. And we may not be able to do it. I hate saying that because I'd like to be able to solve a problem. Yeah, it's way out. 8-9 thousandths out. It could be the bore is no good. Could be, you know, these are Chinese made crap, he said. So it could be a number of things, but this is, I got to have this concentric. I can't do that, otherwise the brake rotor is going to run out. So this is pretty important. I'm making a little progress. I'm going back to opening the jaws up and grabbing it on this surface on the inside again, which is what I should have stayed with to begin with. And the reason is I can get paper in. It's a lot easier than trying to cram it into this spot up in there. And I'm getting pretty close. I got it within 5 thou or so, 7 thou. Trouble is the repeatability is crap. Not sure why. This bore has got to be out around. Tell you what, this is about as fiddly as trying to scratch your butt with a piece of a blade of grass. I swear to God. I'll make sure that this thing is kind of centered where it wants to sit, so it's not being influenced by lateral forces. Now or worse. See, it does not repeat, and it's hard to figure stuff out. Anyway, I'm going to play with it a little bit more. We may have to scrap this, but let me see if I can get it closer than 5 thou. All right, made some progress here. I'm within 4 thou or so. That's where we're going to leave it. Close enough. I can't get it any better. So I tried that, what I was saying before, like for example, this jaw here, 0, 180, and it's +4. This jaw here will 0 it, 180, comes back to 0. Can't do that. Because again, I mean you could do it, but it's not going to read right, because that's only going to really work with a 4-jaw, because you're using opposing jaws to move it X and Y essentially. If you put that on a flat surface, you know, basically, if you put this down on a jaw on a flat surface, you'd be moving X and Y. So it's kind of hard to do that in this because you're dealing with a triangle. And so when you put a piece of paper in here, it affects not only this angle, but the other angles as well because of the interconnectability of a triangle. So if we were looking at a plus sign, that'd be one thing, but we're not looking at that. So how I got this close was through raw experimentation. I started taking out and putting one in, taking out rather and measuring, putting one in and measuring and seeing which jaw made the most impact. Then started adding more and more to that jaw, which was this one here, until it got close. Ended up adding one more of that jaw, there's none in this jaw, and we got it within a couple thou. So 4 thou exactly. So that's going to be close enough, and like I said before, I think this bore is probably a little bit out as far as it being out around. Let's just check the face here real quick. I'm not going to worry about the face too much because it just slips over a bore thing. If it's close and it's within 2 thou, so 3 thou, or actually that's not even 3, that's 2 thou. I keep thinking this is a thousandths indicator, it's a tenths indicator. Thou and a half or so. So that's all right. We're gonna run it. And this was not, if I put this video up, I'll ultimately, I don't even know if I'm gonna, because it's probably gonna confuse the crap out of everybody, including me. This is an example of learning as you go, trying to figure out what in the hell is going on with something and why it's not behaving the way it should when it gets indicated in. And again, because we're dealing with 3 jaws here. 3 jaws is real easy to bump around this way on the face to get it to run true on the face. But you can't do it very well, or at all, hardly, especially on a ID, on a 3 jaw. Bumping it around, shimming it, yeah, but leads me to believe I need to get a batch of shim stock of different sizes, you know, like made out of metal. Maybe it'll be more accurate, but anyway, that was, I'm gonna have to edit the shit out of this to bring it down to where it even seems remotely understandable. But right now what we're gonna do is get a cutter in here, and we're just gonna take a couple thou. We'll end up probably just cleaning it up because this thing, I believe, again, is out of round. But we're close enough to do what we got to do. Customer said he wants to make it work, and we're going to make it work. All right, we got the big bar in because if I use the small bar, I don't have the reach, and the carriage hits the rotor. Rotor's clearing the bed, but not the carriage when it's that close. So what we need to do now is I'm gonna run 600 RPM and 2 thou per revolution of feed. All we got to do is take a few thou off on the side. I figure total of about 4 maybe, because I'm not confident, 100% confident of the measuring the way I did it. I explained that already. So let's make sure we're definitely clear. Yeah. Whoops. Try to turn the power on. Yep, right there. All right, see how it's hitting like that? That's our run out, or the bore being out. I think the bore is out. I mean, I didn't really measure it like in a plus pattern with the snap ring gauge, but the snap ring, yeah, snap gauge. But I think the way this thing is indicating in, it smacks of being out around. Let's double check to make sure this workpiece is definitely still, yep, tight. All right, I'm gonna go ahead and dial in 2 thou, which will give us 4 total, 2 on the side. 4/10 away. All right, here we go. Yeah. It's always some. Got the feed wrong direction. All that work for basically that. That's something. Yeah, but it cleaned it up. So I'm gonna measure it. Well, I don't know if measuring's gonna help me, but I'm gonna measure it anyway. 3.157, and my total, of course, And the total or aggregate of all the other measurements, the side bosses to the inner bore and the bore itself, is 158.5. I'm going to have to trust that somewhat, but if I take this out, I'll never get it set back up right. So we're going to go ahead and just take another 1.5 thou out of it, and all right, a little bit bigger than I wanted. I had to put it back in. What I did was I marked the jaws and marked the piece on the back here with a marker where the number of pieces of paper were on that particular clocking position, so I was able to take it in and out. I actually did it twice. First time it just wouldn't fit, so I only took 2/1000 out. I should have taken one, but that's close enough because the bolts have alignment that go into cap bolts, really, that line this up anyway. So it's the best I can do. But I had to take almost 10 thou out of this thing to get it to clear. That's how far off this stupid crap is. So what I'm going to do is I'm not going to put it in yet because I'm going to cut the other one, try to make it a little snugger. But like I said, I could not get it on. I had to take off a couple more thou. It started, wanted to go on, but no way. That is about right. Because again, these bolts have an alignment feature to them. And these cap bolts anyway. So if we were to start one, you can see what I mean. They're aluminum bolts too. I don't know why he does this stuff. I would never put aluminum bolts on brake parts, but that's just me. So those will, hopefully they fit, but those will go down in there and capture that larger bore here, and it should be okay. Let's put another one in and see. That way we kind of get a representation of how it's going to fit without tightening them all the way down. I mean, this is the type of crap I get stuck doing because it's just junk. I'm not going to say anything. Yeah, so a little bit of a play there, but it's going to be fine. I mean, I'd prefer to be a little tighter, but it is what it is. I can't do anything about it now. As my old man used to say, careful how much you take off because I forgot my putting on tool today. It ain't here. Those are just a little loose now. And that's pretty good. That's only 2 of them in there, so that's aligning pretty good. I don't think you'll have a problem with it, but again, I don't know why he uses these aluminum alloy fasteners. I never would use those, so yeah, I'd say it would work, but man, I had to take almost 10 thou out of there. 8 or 10 thou. Get that to fit. What the hell's up with that crap?
What the hell?
Here's the other one, and pretty much same without any piece of paper in it. So let's go to the jaws that I was using. This one had 3 pieces in it. This one had 4 pieces of paper. So I'm going to do that and let's see what happens. Let's see if that part's repeatable. And would you look at that? Not exactly the same. I've got 5 pieces in this one here, where it said 4. See, this is what I did. Show you. I marked the chuck and I marked the piece. So I put one line there on this one. Let me back off a little bit. I marked the chuck, marked the other piece. So, actually right there on the chuck I put one line, and then over here I put 3 pieces with 2 lines and put 2 little lines there. So when I took it in and out, I just duplicated that. I gotta straighten that out. And then you had pretty much repeatability that way. It did work. In this case, I got 3 pieces. I'm sorry, 1, 2, 3. Yes, 3 pieces there and 5 pieces here. And we're within a couple thou, which is good, which is what we had on the other one. So at least we got some repeatability here. But, you know, I can't explain to you because I don't know enough about them. I'm not, like I said, you want to go to learn about cotangents of the variable of the this and that and the other thing in regards to triangles and geometry and stuff, go see Quinn on Blondie Hack. She explains a lot of that stuff. She's really smart. And I don't get any of that crap. She's like calculus and all the whatever. I mean, I don't really get into it. So, like I said, I fly off the seat of my pants. Usually works out good for me, so I can't explain why, but it has to do with the angles. I do know that. It has to do with the triangle we're dealing with instead of a square or a plus sign. With a 4-jaw, it's so much easier for me, brain-wise, to do, you know, do the highs, do the lows. Bob's your uncle, it's done. But with a 3-jaw, unless you had an independent 3-jaw, which would be nice. That's difficult to kind of explain. So I'm going to cut this one off camera, and actually we're just going to close it out because there's really no need to go into any more of this. But so if I put this up on the channel and I can get it edited to a point where it makes some sense, you see where I go with doing modifications like this using the machine tools to satisfy a particular motorcycle need, which is the whole point of having these things. So anyway, that's it. If you like what you saw, you know what you need to do. Stick around. You see more crap like this and me pulling my hair out on a regular basis. Until then, as always, don't just repair, restore, or destroy.
Destroy!
Ah, fudge!
Whatever. Thanks for watching. We'll catch you on the next video.